Good morning. Welcome to the lecture on biocontrol systems. This lecture we will be focusing on the block diagram reduction techniques for systems which is having multiple input. So far we have discussed on the block diagrams having single input and single output. This particular lecture will be focusing on if we have multiple inputs to a block diagram, then how to reduce them and find the transfer function out of that. So we know that this block diagram reduction technique is a very powerful technique used to reduce the closed loop system into a simple open loop system. Let us take this example where we have two inputs coming from station 1 and station 2. We are supposed to find what is the relation between the output C of S with respect to the first input and the second input. So the possible transfer functions might be correspondingly C of S by R1 of S, C of S by R2 of S in general. If we are considering R1 as the first input and the corresponding output is C1, then I can write C1 of S divided by R1 of S or C2 of S divided by R2 of S. So depending upon our own assumptions, we can try to find the transfer function by using the block diagram reduction technique. So let us consider out of these two cases, let us consider that station 1 is considered first, like case 1, and in case 2 we will consider station 2. While considering one station input, the other station input has to be considered to be 0. So if we say the R of S available here is considered, then the R of S available here is considered to be 0. If you consider that, this particular summing point will be eliminated and you cannot find the summing point here. So this takeoff point A is followed with G3. No summing point is available. Now, without manipulating or moving this takeoff point, I cannot have a cascade or a parallel or a feedback path to be eliminated. So we can move this node ahead of G3. While you are moving, there might be an alteration in this feedback path accordingly. So the manipulation leaves with an addition of 1 by G3 in the feedback path. Now, due to that manipulation, I have a possible combinations that can be eliminated. The first one is the inner feedback path. The second one is after forming this elimination of the inner feedback path, that block will get cascaded with this G2, the second one, which will combine again a single block. Then thirdly, it will end up with again this particular block available in cascade. So we can eliminate all these possible blocks, combining them into single block. Now this block can be multiplied, they are in cascade, so I will end up with something like H3 divided by G3. When you eliminate the inner feedback path, it will be G3 divided by 1, since it is a negative feedback, plus G3H2, and that will be cascaded with G2. So I can write G2 G3 divided by 1 plus G2 G3, it will be G3H2 G2, G3 divided by 1 plus G3H2. So G2, G3 divided by 1 plus G3H2, and you have a feedback here. Now I can eliminate this loop again. So I will get G2, G3 divided by the denominator 1 plus G3H2, and since it is negative again, you will have plus again forward path G2, G3 into feedback path H3 by G3. Then you cancel that, you will get an equivalent form G2, G3 divided by 1 plus G3H2 plus G2 into H3. So that's the equivalent of this particular block. Now that block will become cascade with G1. So I can multiply that. So that becomes G1, G2, G3 divided by 1 plus G3H2 plus G2H3. This cascade is eliminated like a single block, equivalent block. Now that block will be forming a closed loop, inner loop H1 and outer loop H1. So I can combine that by eliminating the feedback G1, G2, G3 divided by 1 plus G3H2 plus G2H3 plus the forward path G1, G2, G3 into the feedback H1. So this is your C by R for the first station, considering the second station's input to be 0. So that is what available here. C of C1 of S divided by R of S is equal to G1, G2, G3 divided by 1 plus G3H2 plus G2H3 plus G1, G2, H3, H1. So case 1 is over. Now we are going for case 2. In that case, we will consider the input for station 2 to be available and station 1 to be considered to be 0. So in this summing point becomes eliminated. So you cannot find the summing point available here. Now from the block diagram, I can find these two blocks in cascade. So if you combine these two blocks, you will get minus G1 H1. And for our easy understanding and manipulation, I can interchange these two. I can move this summing point here. From this summing point can be moved here. Uh, so you can see it here. The manipulation is done. Because of that movement, an addition of 1 by G2 is being added here. Now you can see these two blocks are becoming cascade. So I can write this as H2 by G2, H2 by G2. Now I can interchange these two summing points because I doesn't have any inside a transfer function between these two summing points. Interchanging that will not have an effect over the other blocks, right? So if I interchange, I can have the possible elimination of this inner loop, number one, and I can see these two blocks, this is H2 G2 and minus G1 H1, are arising from a single point. So these two are in parallel. So I can combine these two based on the summing points available here, and that equivalent block will become a cascade if we eliminate this feedback path. So while you eliminate that, this is the equivalent parallel block and the eliminated inner loop feedback path. Now these two are in cascade. So I can multiply them directly, which will end up with this one. Now the entire equivalent block will be in feedback with the forward path transfer function G3 and found to be a positive feedback. I can eliminate the feedback to get a manipulation of final transfer function to be G3 C2 of S divided by R of S is equal to G3 into 1 plus G2H3 divided by 1 plus G2H3 plus G3 into G1 G2H1 plus H2. So this particular feedback path, if eliminated, forms a single open loop system where straight away we can write the transfer function C2 of S by R of S. So if we have multiple inputs available, to find the transfer function of one particular input, the other inputs available in the same system has to be considered to be 0. Thank you.